Alright, so 4.2 is about vertical and horizontal translations of the sine and cosine functions. And you may recall from your previous algebra experience that y equals f of x minus d shifts y equals f of x horizontally by d units. That is, it's going to shift it left or right. Now, what's weird about it is that you actually end up shifting in the opposite direction that you think you would. So if you had like f of x minus 2, that shifts f of x right 2 units. And if you had f of x plus 7, that shifts f of x left 7 units, right? So you go in the opposite direction of what you might think. Now, for trig functions, it works exactly the same way. But these horizontal translations, we call them phase shifts when we're dealing with trig functions. I'm not exactly sure why. And the way that we apply these phase shifts is a little different than the way that you may be used to doing it in your algebra experience. So let's take a look. So let's do some practice. Okay. So let's graph this function. We'll state the amplitude period and the phase shift. Okay. So first of all, as far as amplitude goes, it's got amplitude 1. As far as period goes, well, you're not multiplying x by anything, so the period is still just 2 pi. But as far as the phase shift is concerned, the phase shift here is pi over 3. So that means you're going to be shifting right pi over 3 units. Now, I'm going to start, to graph this function, I'm going to start off the same way that I started in the previous section. I'm going to take the argument, and I'm going to trap it between 0 and 2 pi. And the reason I'm going to do this is because that will let me know, once I've solved for x, it'll let me know what my starting point and my ending point should be. So in this case, in order to solve for x, I need to add pi over 3. So if I add through by pi over 3, I get pi over 3 is less than or equal to x, which is less than or equal to 2 pi is the same as 6 pi over 3. So 6 pi over 3 plus pi over 3 is 7 pi over 3. Okay. So this tells you where to start. This tells you where to end. And remember, you should have 5 special points. So in order to find sort of the 3 points that are equally spaced between these end points, we need to take the period and divide it by 4. So now, how do we figure out the period? Well, a second ago, we said that the period here was 2 pi. And there are a couple ways to see that. First of all, because you're not multiplying this by, well, you're multiplying by 1, I guess, but that doesn't affect the period, right? And the period of the cosine function is usually 2 pi, so the period is unaffected here, it's just 2 pi. That's one way to see it. Another way to see the period is that if you subtract the starting point from the stopping point, you should get 2 pi, right? So 7 pi over 3 minus pi over 3 is 6 pi over 3, and 6 pi over 3 is the same thing as 2 pi. So you can see the period in a couple of different ways. Knowing what the period is important, because then you divide the period by 4 in order to figure out how much you need to add to move from one point to the next. 2 pi divided by 4 is pi over 2. So you're going to add pi over 2. Starting at pi over 3, you're going to add pi over 2, and then again, and then again, and then again. And once you've done that, you should land at 7 pi over 3. Let's make sure that that happens. So we start at pi over 3, and then we're going to add pi over 2. So common denominator there would be pi over 6. You're welcome to just use your calculator, by the way. But so this is 2 pi over 6, and this is 3 pi over 6. So we're going to end up at 5 pi over 6 after the first addition. So plus pi over 2 puts us there. Then we're going to add pi over 2 again. That's 3 pi over 6. 5 pi over 6 plus 3 pi over 6 is 8 pi over 6. 8 pi over 6 is the same thing as 4 pi over 3. Okay, then we're going to add 3 pi over 6 again to 8 pi over 6. That'll put us at 11 pi over 6. And then if we do this one more time, we should end up at 7 pi over 3. Let's see. 11 pi over 6 plus 3 pi over 6 is 14 pi over 6. 14 pi over 6 is indeed the same thing as 7 pi over 3. Okay. And then the amplitude is not affected, right? We're just multiplying by 1. So this should have the same standard pattern as cosine usually does. 1, 0, negative 1, 0, 1. Now when it comes to labeling the axes, this is a little bit tricky. And I think the best thing to do is to get common denominators, so that this is 3 pi over 6, 5 pi over 6, 8 pi over 6, 11 pi over 6, and 14 pi over 6, because you're going to want to try to space them out correctly along the x-axis. So let's do that. So I'm actually going to tick off pi over 6's. So there's 1 pi over 6, 2, 3 pi over 6, 4, sorry, pi over 3 is the same as 2 pi over 6, so pi over 3 would be right there, right? 5 pi over 6, so 1, 2, 3, 4, 5 pi over 6 is here. 4 pi over 3 is 8 pi over 6, so 6, 7, 8 pi over 6. 9, 10, 11 pi over 6. That could have been a little neater. I apologize. Could have gotten these a little more evenly spaced. Anyway, and then 7 pi over 3 is 14 pi over 6. So 11, 12, 13, 14 pi over 6. That's 7 pi over 3. Oh, 8 pi over 6 I should have labeled as a 4 pi over 3. But you see, when you think about it in terms of common denominators like that, then you can make sure that they're evenly spaced, because from here to here is only pi over 3. It's only 2 pi over 6. But from here to here is 3 pi over 6, right? Pi over 2 spaces. So anyway, don't just evenly kind of space them out, or rather make sure you're correctly sort of getting them on the graph. Anyway, these were the important ones that I'm making bigger. Those are our 5 main points. So we're starting up here at pi over 3, 1, and then 0, negative 1, 0, and 1. Okay, so that's what that looks like. We're supposed to state the amplitude, period, and phase shift. So the amplitude we said was 1. The period we said was 2 pi. And the phase shift we said was pi over 3. And that makes sense, right? Because it just looks like the standard cosine function, but it's been shifted right, pi over 3 units. Okay? So there's that one. There's part A. Let's do another. Let's do f of x equals sine of x plus pi over 4. Go ahead and give the video a pause and try this one out. See if you can do it on your own. Okay, here's my solution. Period here is still 2 pi. We're not multiplying x by anything. So we're going to add 2 pi divided by 4, which is pi over 2. But this time starting at negative pi over 4, right? Okay, and then standard pattern, we don't have any amplitude changes, so okay. So this time I've got to put a negative pi over 4 on there, and then pi over 4. And then make sure, right, so this is the space between negative pi over 4 and pi over 4, so I've got to get a more or less equal space to get up to 3 pi over 4. Okay. Whoop. Negative pi. Oh, shoot. See, look at me making mistakes right and left. So none of those are correct. It should go pi over 4. Sorry, negative pi over 4, then pi over 4. Okay. There we go. This is what it should look like. Anyway, word to the wise, don't use a pen on a test or a quiz. Use pencil so that you can erase nonsense like that. Okay, so there's that one. Okay, let's do another. Let's do f of x equals 2 sine of x minus pi over 4. Okay. All right. So this starts off the same way. We add pi over 4. 8 pi says 9 pi over 4. The period is still 2 pi, so we know that we're going to be adding pi over 2, so I'm not going to write all of that out. For the sake of space, I'm just going to write my chart going this way. But we're going to start at pi over 4, and we want to end at 9 pi over 4. We're going to get there by adding pi over 2 each time. So if I add pi over 2, that's the same as 2 pi over 4. So I'm going to end up at 3 pi over 4. And if I do it again, and again, and again, and now for the sine function, same pattern as usual, right? Oh, but I'm multiplying by 2. So 0, 2, 0, negative 2, 0. So pi over 4 is there. And then there's pi over 4. There's 3 pi over 4. 4 pi over 4, 5 pi over 4. 6 pi over 4, 7 pi over 4, 8 pi over 4, 9 pi over 4. Okay, so 0, 2, 0, negative 2, 0. Alright, I forgot to do this on the last problem, but we should state the period, amplitude, phase shift, all of that stuff, right? So the period here is 2 pi. The amplitude is 2 in this case, and then the phase shift, it looks like pi over 4. Okay, so that's that one. Okay, I want to give you one more example. This time we'll throw in a change in period as well. So we're throwing in the baby or throwing in the whole kitchen sink, I guess. Or what is the phrase? Everything but the kitchen sink, I guess. Okay. Negative 2 cosine 3x minus pi over 2. Okay. So let's do this. So I'm going to start off graphing this the same way that we usually do. I'm going to pin 3x minus pi over 2 between 0 and 2 pi, and then solve for x. So to solve for x, first I would need to add pi over 2. Two pi is the same thing, 4 pi over 2, so this would be, if I add pi over 2, I get 5 pi over 2. And then the next thing I need to do is go through and divide through by 3. So if I divide through by 3, I'm going to get pi over 6 less than or equal to x less than or equal to 5 pi over 6. Okay. Now if you're thinking about what is the period, it's 2 pi divided by 3, right? Because we're multiplying x by 3. So the period is 2 pi over 3. So what are we going to add? We're going to add 2 pi over 3 divided by 4. So that's pi over 6. So we're going to add pi over 6. Okay? Starting here and ending there. Let's do it. So we're going to have pi over 6 plus pi over 6 plus pi over 6. That's 3 pi over 6 plus pi over 6. It's 4 pi over 6 plus 5 over pi, plus pi over 6 puts us at 5 pi over 6. Exactly where we wanted to land, right? So we're starting here, we're ending there. We did it in 1, 2, 3, 4, 5 points. And we got there by adding pi over 6 each time, right? Okay, now the y-coordinates we need to multiply by negative 2. And this is the cosine function, so we're usually starting at 1, but 1 times negative 2 is negative 2. Then we go to 0, and then down to negative 1, but negative 1 times negative 2 is positive 2. And then 0, and then back at negative 2 where we started. And now we can plot these points. So pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. Okay, and plot the points. There I go again, making mistakes. Okay, see, I wish we were in class, because in class you would all be yelling at me, and then I would know, oh, I've got to stop. Sorry, we're starting at pi over 6, not at 0. So it's pi over 6, negative 2. Pi over 3, 0. Pi over 2, 2. 2 pi over 3, 0. And then 5 pi over 6, negative 2. There we go. Okay, so that's what that one looks like. I want to talk to you about the phase shift on this one, because when you look at this, at first glance, it seems like the phase shift is going to be pi over 2. And yet, we only ended up shifting it over pi over 6. So the phase shift is really just pi over 6. And why is that? Well, one way that you could see that is if you rewrite this function as follows. If you factor out the 3, then this is what you get, right? So if you factor out the 3 from this group, right, imagine distributing this back in, you get 3x and then 3 pi over 6, which is the same thing as pi over 2, right? So this is what you get when you factor out the 3. And lo and behold, there is the phase shift, right? There is the phase shift. So if you rewrite the function this way, then you can see the phase shift right off the bat. Okay. But anyway, the period on this one was 2 pi over 3. Okay. You can see that in a couple of ways. You can either see it by saying, well, the period of cosine is usually 2 pi, so since I'm multiplying by 3 here, the period is going to be 2 pi divided by 3. That's one way to see the period. The other way to see the period is to use what you did here, do 5 pi over 6 minus pi over 6. That's 4 pi over 6, which is the same as 2 pi over 3, right? But anyway, so the period is 2 pi over 3. The amplitude is 2. And the phase shift is pi over 6. Okay, so there's that. Now, we can make things just a tad bit even more complicated, and that is we can do that by introducing vertical shifts, right? So you may recall that y equals f of x plus c shifts y equals f of x vertically by c units. Now these ones, they go in the intuitive direction. So if you have like f of x plus 2, that shifts f of x up 2 units. If you have f of x minus 6, that shifts f of x down 6 units, right? So it goes in the intuitive way. So let's practice. So let's graph a couple functions. We'll state amplitude, period, phase shift, and vertical translation. Okay, so let's do all of that. For f of x equals -1 plus 3 cosine 2x plus pi. All right, so these are about as complicated as they get. All right, so let's do this. We're going to start off the same way. I'm going to trap 2x plus pi between 0 and 2 pi, and then solve for x. So I should subtract pi first, and then divide by 2. Okay, so that gives me my starting and stopping points for my 5 special points. For the 3 points in the middle, I need to figure out what the period of this function is and then divide it by 4. So since I'm multiplying by 2 here, the period is going to be 2 pi divided by 2. That's just pi. So what I need to add is pi divided by 4. Okay, so let's do it. I'm starting at negative pi over 2. So negative pi over 2, and if I add pi over 4, I'm going to get negative pi over 4. And if I add pi over 4 again, I'm going to get 0. And then again, and then again. And sure enough, I end up at my stopping point, right? So I'm getting that by adding pi over 4. Okay, so that's taken care of. Now, for my outputs, now I need to do 2 things. I need to multiply them by 3, and then I need to subtract 1. Okay, so for cosine, I'm usually starting at 1, but now I'm going to multiply by 3 and get 3, and then I'm going to subtract 1 and get 2. Then I usually go down to 0. 0 times 3 is 0. 0 minus 1 is negative 1. And then I usually move down to negative 1. Negative 1 times 3 is negative 3. Negative 3 minus 1 is negative 4. Then I usually come back up to 0, but in this case I'm going to be returning to negative 1, since 0 times 3 is 0, and 0 minus 1 is negative 1. And then from there I usually return back to 1, but in this case I'm going to be returning to 2, since 1 times 3 is 3, and 3 minus 1 is 2. Okay. Now let's plot the points. There's 2, there's negative 4. And, oh, I should have given myself more space over here. That's okay. This is negative pi over 2, negative pi over 4, 0, pi over 4, and then pi over 2. So I didn't need quite so much excess graph paper over there. But anyway, let's plot these points now. I'll try to be more careful this time. So I've got negative pi over 2, 2. Negative pi over 4, negative 1. 0, negative 4. Pi over 4, negative 1. Pi over 2, 2. Okay. And so that's that one. We can do period, phase shift, all that. So period here, we already figured out a second ago, the period was pi, right? Amplitude is 3. And phase shift. Well, it looks like we went left pi over 2, so I would say negative pi over 2. And remember, another way to see what the phase shift is to rewrite this by factoring out this first number. So this is really negative 1 plus 3 cosine of 2 times x plus pi over 2. Right? If you factor out the 2, that's what you get. So there you go. You can see the phase shift is negative pi over 2, for sure. Okay? So that's that one. One more. I'll let you work on this one. So let's do f of x equals negative 2 sine of x minus pi over 2 plus 4. So go ahead and give the video a pause. See if you can work that one out. Alright, here's my solution. No change in period on this one, so that's kind of nice. We add pi over 2 through. This is 4 pi, so 5 pi over 2. Okay. Period is 2 pi, so we're going to add 2 pi over 4, which is pi over 2. So let's do that. Starting at pi over 2, right? So we add pi over 2, we add pi over 2, we add pi over 2, and then we add pi over 2, right? We do that 4 times. And that gives us our 5 points. Now sine usually starts at 0. I'm going to be multiplying these by negative 2 and then adding 4. So 0 times negative 2 is 0, plus 4 is 4. Then we go up to 1. 1 times negative 2 is negative 2. Negative 2 plus 4 is 2. Then we go back to 0. Then we go down to negative 1. Negative 1 times negative 2 is 2, and 2 plus 4 is 6. Okay. And then finally, we come back to 0. Right? 0 times negative 2 is 0, plus 4 is 4. And now I can just plot those points. Okay. So pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2. Okay, and we're starting here and going down to here and back up and back down. So there's one period of this particular function. Okay. Okay, period, amplitude, phase shift, all of that. We said the period was still 2 pi. That wasn't really changed. The amplitude is 2. And the phase shift is pi over 2. Okay, and that'll do it for that problem. Okay, so this is how graphing goes with sine and cosine. We'll talk about tangent, cotangent, secant, and cosecant in the next 2 sections. But that's it for now.